one, we're going to express the function as a sum of a power series by first using partial fractions, and then we're going to find the interval of convergence. So let's do the partial fraction part first. We can rewrite this as equal to 3 divided by x minus 2 times x plus 1 equals a divided by x minus 2 plus b divided by x plus 1. Now clearing the fractions, we'll get 3 equals a times x plus 1 plus b times x minus 2. Now let's let x equal 2. If x is 2, this b goes away, and you're going to get 3a equals a. So a is going to equal 1. And then let's let x equal negative 1. And then if it's x is negative 1, the a goes away, that zeroes out here, and you're going to get 3 equals negative 3b. So b is going to be negative 1. So that's what we have is our function here is equivalent to 1 divided by x minus 2 minus 1 divided by x plus 1. Now what we want to do is our goal is to write our function in the form of 1 divided by 1 minus r, and then do the absolute value of r is less than 1. So to do that, we're going to use this equation to do it. So we want it to look like this equation. So what we're going to do is factor out negative 1 divided by negative 2. And that's going to give me, for the first one, I'm doing this first one, 1 divided by 1 minus x divided by 2. Now it looks like this. All right, and then for the second piece, we have minus, and I can write this as 1 plus x. So this is going to be 1 divided by 1 minus a negative x. And I'm going to try to squeeze this in here. So for this first piece, this one right here, this would be negative 1/2 times the sum, and I'm looking at this, of, this is your x, so this is going to be x divided by 2 to the nth power. And then we have minus our sum, n equals 0 to infinity, and we have negative x. So this is going to be negative x to the power of n. Now I'm running out of room, so I'm going to copy this down, and then we're going to find our intervals of convergence. So just bear with me and let me copy this down again. So we had this equals negative 1/2 times the sum, n equals 0 to infinity, x divided by 2 to the nth power, minus the sum of n equals 0 to the negative x times negative x to the power of n. All right. Let's go ahead and simplify this to a form that's better to see, but this is the one we're going to use to find the interval of convergence. So before we do that, let's just rewrite this as the sum. Now, n equals 0 to infinity, and I'm going to pull in this negative 1/2. And then this is going to be 1/2 to the nth power minus, now for this piece, I'm going to get negative 1 times negative 1 to the nth power. And then I'm going to, we still have this x to the nth power, so multiply it by x to the nth power. So this simplifies to the sum from n equals 0 to infinity. And simplifying this, we get negative 1 to the n plus 1 minus 1 divided by 2 to the power of n plus 1. And then this is to the times x to the power of n. But going back to, this is a better way to write what we have from here. But we're looking at this piece to find our interval of convergence. So for the first piece, again, we wanted to write it as 1 divided by 1 minus r, absolute value of r. This is our r. So absolute value of x divided by 2 has to be less than 1. So absolute value of x is less than 2. So the interval of convergence for the first piece, by definition of this, is you can write this as -2 is less than x is less than 2, which is -2 to 2. For the second piece, we have the absolute value of -x is less than 1, or you could just say absolute value of x is less than 1. So that means our interval of convergence is -1 to 1 for the same reason, by definition. So this is your interval of convergence for this one, and this is your interval of convergence for this one. However, since they have to go together, we have to choose this one because of this one does not work for the second piece. This is a smaller interval, so the whole thing only converges when x belongs to -1 through 1, and that's your interval of convergence. Thank you. Have a nice day. Bye-bye.